number 5 from our unit of sequences and series. This will be the last video where we use the formula sum of arithmetic series, which we've used in the last video. In this video we'll also be exploring the use of a quadratic formula, but I'll get into that as the need arises. Well, let's get started on a question that looks a bit different to everything else we've approached so far. Let's call this question 1. After how many terms does the series 7, 12, 17, 22, 27, etc. equal to a sum of 4,599? Alright, so in this case we've been given the sum. We've got a sequence of 5 numbers we can use, but we don't actually know where this series stopped to be calculated to get this particular sum. In other words, we need to solve for n. Alright, just like anything, we've got to check what formula are we actually going to use here. Well, I need to check first up whether it's arithmetic or geometric. So let's have a look at this. 12 take away 7 equals 5. I'm going to see if the common difference of 5 works every time. 12 plus 5 is 17, 17 plus 5, 22. It works. So I've got an arithmetic sequence on my hands. I'm dealing with the sum because I was given a sum and I'm trying to solve for n. So I am going to be using this formula here. Well, like every other time, we start by writing out the formula we're going to use. So let's do that. The sum up until the nth term is the same as n divided by 2 times 2a plus n take away 1 times d. Just because I haven't put the multiplication sign in, we know it's there, just remember that. We now have to figure out what have we actually got, alright, from our information provided. Well, I do know S, I know the sum, okay? So S is in fact 4,599. N is unknown. A is the first number in the sequence, it's 7, and our difference was a positive 5. Okay, so I've written all our information there. So let's just plug it into a formula and see what it looks like. We have 4,599 equals n divided by 2 because n is still unknown. 2 times, well, a is 7, so I'll put that in there, plus n is still unknown, times 5. Put the brackets around there. Alright, now like always, I tidy up what I've got, okay? Bracket inside a bracket, now I'll have to expand that out. 5 times n is 5n. 5 times negative 1 is negative 5. Okay. 2 times 7 is 14. I've got that bracket sorted. N divided by 2, whoops, remains as is, so does our sum. Okay, I can tidy this up further by looking first of all at our like terms. I have 14 and I've got minus 5, so what's 14? Take away 5, we've got 9 plus 5n. That is still in a bracket, and we've got n divided by 2 times that. Alright, remember the name of the game is to get n by itself, but we haven't fully tidied up this equation. Okay, so let's apply our algebra that we know. I'll use a different colour to show you these steps. I need to get rid of the divided by 2 first. How do I do that? I do the opposite of divided by 2, times 2. Remember, on one side of the equals, if I do that, I must do it to the other side. Times 2. Well, 4,599 times 2 gives me 9,198. Alright, what does my equation look like? From there, it looks like this. I now need to expand this bracket, just as I did up there. So everything inside that bracket must be multiplied by n. So what does that look like? I'll do that in a different colour as well. N times 9 is 9n plus 5n times n gives me 5n squared. Now I've got an addition of two terms here, and they are not like terms. This one has a power applied to it, this one does not. So we can't just join them together and call them 14n, because we don't know whether to call it n squared or not. It's not multiplied. Now to solve for n, I need to make this equation equal 0. Okay, so we need to get rid of the constant from this side. Well, how do we do that? We subtract that total from there. What we do on one side, we must do to the other. Well, that now gives me 0. Now, none of these are like terms, they're all different, but let's arrange them in a more algebraically acceptable order. 5n squared, remember, that's that whole tile. That's a positive 9n, so it's plus 9n. And finally, take away 9198. Okay. Now, if you look at that equation there, we actually have a quadratic equation. It's quadratic because we have a power, a squared unit here, a coefficient, and a constant. And this is what the quadratic formula looks like. So we do have an equation similar to this. This is a quadratic equation, and that brings us to the quadratic formula, which we're going to use to solve for n. Okay, remember, a variable can be any variable. Solve for x, the unknown variable. Okay, in this formula we have three variables. We've got an a, a b, and a c. Now if we look at our quadratic equation, okay, a is the coefficient with the power. Okay, so that would go in here and here. B is the coefficient, okay, and C is the constant. That's the easiest one to remember, okay. But if you set your quadratic equation up in the correct order with your power first, followed by coefficient, then constant, then you've got your A, B, C. They're easier to label. So if you remember to do that, we'll be all good. So let's come back to what we've got here. Let's label our equation here. Okay, now just like anything, when you go to use a formula, you should always write the formula out. Okay, n equals negative b plus or minus the square root of b squared take away 4ac divided by 2a. I've labelled in my quadratic equation what our a, b, c is. Now I'll just need to make sure I substitute those in correctly. Be really careful if there is a negative that we put it in there correctly, because if you don't, you'll probably end up with a calculator error. So let's go ahead and do that. N equals negative 9. Now I've got a plus or a minus. I'm going to deal with adding first. I have to do the equation again with the subtraction and then check which one of the answers makes sense. Okay, negative 9 plus the square root of 9 squared. I'll put this in brackets just to remind us that we must solve that first. Minus 4 times a is 5 times what is c, a negative 9,198. Just be really careful that you're multiplying that negative number and dividing that entire part of the equation by 2 times a is 5. Now we'll go through and tidy up this equation. Alright, I can't tidy that up, so I'll just rewrite it. I'm going to do the bit inside the brackets, and I can do that part straight up in my calculator. So we've got 9 squared, take away 4 times 5 times negative 9198, and that gives me 184,041. Alright, divided by 2 times 5 is 10. Now I need to find out what is the square root of this number here. Okay, just so I'm tidying up as I go along. I know I haven't tidied up this bit yet, so I'll just write that. Square root, there's the button there, of 184041. Just double check your number is the same. That gives me 429. Okay, divided by 10. Solve this up the top and then divide. I'm going to shortcut it though. I'm just going to go through and I can plug it in as a fraction. Negative 9 plus 429 divided by 10 gives me n equals 42. Okay, now that actually looks like it would make sense, but let's just go through and remember we just did the addition of that. We are now left to do the subtraction of it. Alright, now that only applies to this point here, so we don't have to go through and do the whole equation again. We can just redo this equation, but it will look like this instead. N equals negative 9 take away 429 divided by 10. Let's put that in our equation. Negative 9 take away 429 equals, divided by 10, n equals negative 43.8. Now here were my two answers, this one and this one. Now let's think about what were we looking for. We were looking at which term in the sequence, in the series, gave us that particular sum. We can't have a term sitting at negative 43.8 in a sequence. That doesn't make any sense. So this one here doesn't apply. It doesn't make any sense. But when n equals 42, the 42nd term, and we can test that out. Okay, we can just plug that back into our equation. Where was our quadratic here? We can plug it into here and check it equals 0, or we could in fact plug it back into this equation here in blue to see if it works. So we'll do that both ways. If n is 42, okay, if I plug it into this equation, I will end up with 5 times 42 squared plus 9 times 42, take away 9,198. Or if I choose to plug it into this equation, my equation will look like this. 98 equals 9 times 42 plus 5 times 42 squared should equal that. Or I could go back through and plug it in to this equation here, which would give me 4,599 is the same as 42 divided by 2 times 9 plus 5 times 42. It shouldn't matter which one I choose. I should always get the same answer. Bruce rang, by the way. I'll just cut that out, it's right. So let's go through and try. 5 times 42 squared plus 9 times 42, take away 9198, gives me 0. Just to prove it didn't matter which equation we plugged it into, 9 times 42 plus 5 times 42 squared gives me 9,198. That is also correct. And lastly, if I put it into the original sum of arithmetic series formula, 42 over 2 times 9 plus 5 times 42 gives me 4,599 as well. Okay, so again, it wouldn't matter. We know that once we found the nth term, we just put that value in and solve to check if it works, and we answer the question, after how many terms does the series 7, 12, 17, 22, 27 equal to a sum of 4,599? After 42 terms, okay, or at the end of the 42nd term, right? If you feel confident with those, have a go with these questions here. We just did number 1 together. Have a go at number 2 and number 3. I'll post the answers at the end of the video. Good luck with that, boys. If you have any problems, get in contact with me, you know how, and we'll catch up with you later.